Today I'd like to talk about replacing a rotted out fence post in a difficult location. This fence post is rotten, and since it's surrounded by concrete, I really can't just dig it out. Before I knew how to weld, I had to put in a temporary repair. This involves using a tool called a roto hammer. It's designed to use special drill bits and chipper bits to drill holes or break up concrete, essentially a mini jackhammer. I chipped away the small portion of concrete holding the post that I actually had access to. Now, when a post rots, it normally rots right where it enters into the concrete. So as a temporary support that lasted about 5 years, I fastened metal supports to the good wood above and below the rotted out portion. Today, we're going to get rid of this temporary fix and mount the post above ground with this metal bracket. Before we can get started, the first thing we have to do is remove all the fencing that's attached to the post. This fence is stapled, so you can pound out the first board by just tapping it on the back side. With that first board removed, you can now use your pry bar to remove the rest of the boards. Our goal here is not to damage any of them. Remove the boards that was holding the lattice. Usually it's only held in by a couple very large nails. The remaining boards are toe-nailed, which are easy to remove if the heads are exposed. If the heads are not exposed, break out your Sawzall and put a metal cutting blade on it. That blade will cut right through that nail. And since we're using brackets to put it back together, we don't care if the nail is left in. That should about do it. Let's see how rotten this post was. All of the plumbing that you see is one of my sprinkler manifold systems, which is another good reason for not digging holes in this area. Yep, pretty rotten. At this point, we need to remove the remaining wood that's still in the concrete. The tool of choice for this job is the 1/2-inch power drill. It'll be driving this 3/4-inch auger bit. Auger bits are designed to bore a large hole in a short period of time. And I picked this size drill bit because it's a convenient size for driving these metal spikes into. You should be able to pick up these spikes in any large box store that sells concrete supplies. I think they're used to hold formwork in place. You want to drill as many holes as you can, as deep as you can, in the wood that's still remaining. Now you can take the metal spikes and a 3-pound sledge and drive them into those holes. Then you can use the spike as a lever to physically bust the wood out. As you get deeper into the hole, that's where your longer spikes come into play. Ah, that's what success looks like. When you're all done, this is what your post will look like. You won't be able to get every single sliver out, but you can try to get as much as you can. Up to this point, we've managed to get the post completely removed, while leaving intact 3/4 of the original concrete holding the post, as well as most of the surrounding sidewalk concrete. Now, conceivably, you could try to fit a new post in here. More than likely, it won't fit. It'll either be too small or too large. And I personally never want to deal with this problem again, so I've come up with a way to mount the post above ground. And that solution lies in the wonderful world of welding. This heavy-duty bracket will be mounted on the bottom of my post. The entire post will be above ground and be easy to replace if something should happen to it, while the long round metal rod will be mounted in the hole that we just made and surrounded by concrete. I apologize for not having video footage of making this bracket. It seems that footage was a victim of the last time I purged a couple terabytes off my computer. But I will refilm my next bracket and post that. So, when I built it, I deliberately made it slightly smaller than the post that was going to be mounted in it. This is because I wanted an extremely tight fit. So then I used a belt sander to take just a small amount off the end of the post, then a 3-pound sledge to drive it into place. When I built the bracket, I made one side considerably longer than the other two sides. The reason? This side of the post will take considerable punishment from a gate that closes on it on a regular basis, so the longer piece of steel effectively reinforces that side of the post. To attach the bracket to the post, I used Torex head, self-tapping, 4-inch long screws designed for exterior pressure-treated wood. A length of 4 inches means you'll get maximum amount of threads in the wood, and a Torex head means you can remove this screw later. There are 9 screws on 3 sides of the wood. I went with screws instead of lag bolts because this post has very little stress actually put on it. As you saw when I tore it apart, the surface area of the fencing is very minimal, and the amount of wind that we get in our area is usually less than 40 miles an hour. If you're doing this repair on a larger fence or in a place with more wind, I definitely recommend upgrading to lag bolts. The other thing I'd like to talk about is the metal rod attached to the bottom of the bracket. You want that to be as long as possible. In the last video I posted, I explained the dynamics and mathematics of why the wind pushes a fence over. And you'll see in this video, if you follow the link above, why this rod has to be so long. And if you live in a windy place, you may need more than one rod. Anyway, moving on. Put your new post and bracket into place. The metal rod will be centered where your old post used to be. To temporarily hold your post in place, run some long boards between the two existing fence posts on either side. Attach them to your new post. What we have here is 4 1-gallon bags with 10 pounds of concrete in each bag. This is the way I store my concrete. Go to the hardware store and you buy it. It comes in a 50, 60, or 80-pound paper sack. That paper sack allows moisture to get to your concrete, which in turn causes it to set up, which now means you can't store it long term. Ziploc bags are both watertight and airtight. This does allow long-term storage of your concrete, and you store it in small enough quantities you can use it for small projects, with no waste. Let's pour some concrete. I stopped the concrete far enough down so that we can install pavers. However, this caused one small problem. The concrete really has to come up to the bottom of your bracket. So, break out another bag of concrete and start pouring again. This time you're going to use a little formwork to hold the concrete in place while it's curing. After the concrete is cured, pull your formwork off. Now it's time to rebuild your fence. When you're all done, you'll find shaking the fence posts is a much different result. It's sturdy now. And while you're rebuilding the fence, you might want to consider an improvement to the gate, using a pair of large magnets to hold the gate closed. This results in easy, hands-free opening, and you never come home to find the wind has blown your gate open because of a mechanical latch failure, and the gate has a tendency to close itself. I'll post a video on how to do this. Well, thanks for watching.